Okay, page 8, which is derivative of logs. From your investigation, or from page 376 of the book, write down the derivative of the function natural log of x. It is 1 over x. Using the chain rule, write down the derivative of natural log of f of x. Okay, so when you have a function inside instead of x, then you need to do 1 over x, and then after that, you're I'm sorry, 1 over f of x, right? 1 over f of x. And then after you do that, you have to multiply that using the chain rule times the derivative f dash x. Okay? So recall the laws of logarithms which can facilitate differentiation. Remember that the natural log of a product AB is equal to the natural log of A plus the natural log of B. The natural log of A over B is equal to the natural log of A minus the natural log of B. And finally, the natural log of A to the nth power is equal to n times the natural log of A. So those are the three rules that you can use to rearrange the natural log functions to make them easier to take the derivative of. Okay. So let's start with A. Y equals the natural log of 7x. So let's take the derivative. When you take the derivative, first thing you're going to do is say, 1 over whatever's inside, which is 1 over 7x. And then you're going to have to take the chain rule. So you take the chain rule, or the derivative of 7x, you get times 7. Okay? And then, interesting, the 7 cancels out with the 7x, and you get 1 over x. Okay? Alright, C. So you have natural log of x minus x squared. So the first thing you're going to do when you take the derivative is you are going to write 1 over whatever is inside, which is x minus x squared. Then you're going to multiply times the chain rule. So you're going to have 1 minus 2x, right? Alright, E. You're going to have x squared times natural log of x. So this is not just the derivative of natural log. This is a product. So what you're going to have to do is you're going to say, hey, u equals x squared, v equals natural log of x, u dashed equals 2x, and v dashed is equal to 1 over x. Okay. So I'm just going to rewrite this because I wrote it really messy. Okay. So when you take the derivative of this, it's going to be u, x, which is x squared, times v dashed, which is 1 over x, plus u dashed, which is 2x, times v, which is natural log of x. Okay, so this is going to be equal to x squared divided by x is x, plus 2x times natural log of x. Alright. G. Y is equal to e to the x times natural log of x. Again, this is a product. We know how to take the derivative of e to the x. We know how to take the derivative of natural log of x. We don't know how to take the derivative of e to the x natural log of x, but we do know how to handle products. So we'll say u is equal to e to the x. U dashed is also e to the x because the derivative of e to the x is e to the x. V is equal to natural log of x. V dashed is equal to 1 over x. Okay, so now we're just going to use the product rule. We're going to say, okay, it's going to be e to the x times v dashed, which is 1 over x, plus u dashed, which is e to the x, times v, which is natural log of x. Okay, so that's the derivative of that. What about I? Y is equal to the square root of natural log of x. Okay, now, so this is not a product. This is a composite function. A function inside of a function. Let's rewrite it so it's easier to see it as the power rule. So we're going to put natural log of x on the inside, and we're going to put to the 1/2 power on the outside. Now remember what I was saying in the investigation, the examples we used for, product rule and, what do you call it? Chain rule. Sometimes we're like so easy that we didn't see what the point was, but now they're starting to give us some difficult ones that, the only way we're going to take the derivative of these are with the product rule or with the chain rule, etc. So here, we are going to take the derivative of that, and of course we're going to do the power rule, and the power rule simply says put the 1/2 in front, put the whatever's inside keep it inside, and then we're going to do a power which is 1 less than the original power, and then we're going to do the chain rule. The derivative of natural log of x, of course, is 1 over x, so we just multiply that times afterwards. So that's it. What about k? This is product, right? This is a product of two things we know how to take the derivative of. So let's say that u is equal to square root of x, also known as x to the 1/2. U dashed is equal to 1/2 x to the negative 1/2. V is equal to natural log of 2x. V dashed is equal to the natural log of 2x times the chain rule would be 1 over, the derivative of natural log of 2x would be 1 over 2x, and then the chain rule would say we multiply it times 2. Okay, and then, oh, look at that, the 2's cancel out, and then you end up with 1 over x. Okay, so now the product rule tells us that we're going to put x to the 1/2, which is u, multiply it times v dashed, which is 1 over x, add that to u dashed, which is 1/2 x to the negative 1/2, multiply that times v, which is natural log of 2x. And so that simplifies a little bit. It'll simplify to x to the negative 1/2 plus and then 1/2 x to the negative 1/2. That doesn't really simplify at all, but x to the negative 1. We could factor out the x to the negative 1/2, but I'm not sure if that would really make it any better. Okay? Alright, m. The derivative of y equals 3 minus 4 times natural log of 1 minus x. Okay, so let's see. Derivative of 3 is 0. Derivative of negative 4 natural log of 1 minus x is going to be 1 over 1 minus x, and then we take the derivative of the 1 minus x, which is the inside part of natural log, and we get negative 1. So we can simplify that, multiply negative 1 times negative 4, we get 4 over 1 minus x. That's it. Okay, what about 2? Find dy dx for, and then now it gives us, it's just the same thing, they're just like asking for it in a different way. First they say find the gradient function, then they say find dy dx. It's the same thing. They're just trying to get used to like the different language. So here, look at the natural log of 5. That is just a constant because there's no x there. So you don't have to do a product rule or anything. This is just saying, hey, look, x times natural log of 5. If you take the derivative of that, it's just natural log of 5 because it's just like saying 3x. The derivative of 3x is 3. The derivative of natural log 5 times x is natural log of 5. Okay? That was kind of, they're trying to trick you. Make you think it's harder than it is. Okay, the derivative of natural log of x to the 4th plus x. Now this is a function inside of a function, so you're going to have to use the chain rule. Okay, so the first step is to take the derivative of natural log, which is 1 over x, or in this case 1 over x to the 4th plus x. And then you're going to take the chain rule and then take the derivative of x to the 4th plus x. You're going to get 4x plus 1. Okay, multiply that. Okay? Alright. E. Y is equal to the natural log of blah, 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 cubed. This is a function inside of a function inside of a function. So let's see. First thing we're going to do is we are going to do the power rule. Okay? So if we do the power rule, we're going to put the 3 out front, and then we're going to leave natural log of 2x plus 1 in the inside. And then we need to take the derivative of natural log of 2x plus 1 in the chain rule. So that would be 1 over 2x plus 1. And then when we do that, we need to take the derivative of the 2x plus 1 with the chain rule again. And so that would be 2x plus 1. Instead, it would just be 2, right? So if we want to simplify that, we could multiply the 2 times the 3, and we get a 6. In the numerator, we would have natural log of 2x plus 1. In the denominator, we would have just 2x plus 1. Okay? G. Y equals the natural log of 1 over x. So if we take the derivative of that, it's a function inside of a function, so we're going to use the chain rule. we're going to have 1 over x. And then we take the derivative of 1 over x. Remember, 1 over x is x to the negative 1. So if we take the derivative of that, it's just saying negative 1 x to the negative 2, right? And now we can definitely simplify this. 1 over x is equal to x. And then we multiply that times negative 1 x to the negative 2. Remember, x to the negative 2 is actually x squared in the denominator. So we now have negative 1 over x. Interesting. Okay. Now, this I, we have y equals 1 over natural log of x. This, again, is a function inside of a function. So the main function is 1 over something. So if we have 1 over something, that's the same thing as saying natural log of x to the negative 1, right? So first we use the power rule. We say negative 1 times whatever is inside natural log of x to the negative 2. And then we need to take the derivative of what's inside, chain rule. So natural log of the derivative of natural log of x is 1 over x. Okay? Yeah, and that's it. There's no chain rule after that. Okay. 3. Use the logarithm laws to help differentiate with respect to x. Okay, remember the logarithm laws? They're these ones here. Okay? Alright, first one. Y equals the natural log of square root of 1 minus 2x. Okay. Let's see. So, this is the same thing as natural log of 1 minus 2x to the 1/2 power. And remember, from the rules, if you have natural log of something to a power, then you could put the power out front. So, hey, that's neat. You could put the power out front. So you put 1/2 natural log of 1 minus 2x. We've already simplified it. Now it doesn't have a square root inside of a natural log. Now it's just a simple coefficient there. So if we take the derivative of that, it's going to be 1/2, and then the derivative of natural log 1 minus 2x is 1 over 1 minus 2x, and then we use the chain rule and we multiply times negative 2. Okay? What about C? Y equals the natural log of e to the x times square root of x. This is the same thing as doing natural log of e to the x plus natural log of square root of x, which is x to the 1/2. Okay? And remember, natural log of e to the x is natural log and e undo each other. So this is just x. And then, and we're not even taking the derivative yet. We're just simplifying, right? And then we have plus, and then we have the natural log of x to the 1/2, but we can put the power out front because of the log rule. So now we just have 1/2 natural log of x. Now we take the derivative of this. So the natural log of x is 1. The natural log of 1/2 log x is 1/2, and then the derivative of natural log x is 1 over x. So we have 1 plus 1/2, 1 over x. Okay? Alright, E. I didn't leave very much space for me to do this. First we're going to simplify. This simplifies to, and I'll write an equal sign because actually it's an equals. I'm going to put natural log of x plus 3 minus the natural log of x minus 1. And then I'm going to take the derivative of it. So the derivative of natural log of x plus 3 is 1 over x plus 3. Even if we do the chain rule, the derivative of x plus 3 is just 1, so that doesn't really change anything. Then we take minus, and now we're going to take the derivative of natural log of x minus 1. That will be 1 over x minus 1. Again, with the chain rule, nothing else happens, so we're done. Okay? Alright, now we go down to G. F of x equals natural log of, and then we have 3x minus 4 cubed inside here. Let's see how we can, we can like take the power and put it out front. Remember, there's this rule that says that if we have a to the n inside the natural log, we can put the n out front. So let's do that. So we're going to put the 3 out front, and then we're going to have natural log 3x minus 4, right? And then, now we're going to take the derivative. So when we take the derivative, we're going to have 3 times, and the derivative of natural log of 3x minus 4 is 1 over 3x minus 4. And then we take the chain rule. So the derivative of 3x minus 4 is 3. Okay? So we can simplify that. We have 3 times 3 is 9 over 3x minus 4. Okay. Now we do I. F of x equals natural log of this quotient. And remember, when you have a quotient, it's the same thing as natural log of x squared plus 2x minus natural log of x minus 5. Now we're going to take the derivative of each of these. The derivative of natural log x squared plus 2x is 1 over x squared plus 2x. Of course, we need to do the chain rule. We're going to multiply it times 2x plus 2, which is the derivative of the denominator. Then we do the derivative of natural log of x minus 5. We put 1 over x minus 5, and with the chain rule, nothing happens because the derivative of x minus 5 is just 1. Okay? So that's it for I. Finally, the last one, number 5. Suppose that f of x is equal to a times the natural log of 2x plus b, where f of e equals 3 and f dash e equals 6 over e. Now, e, there's a reason why they put e in there, because it undoes natural log, so, they're trying to make it simple. Okay, find the constants a and b. So they said that if we put e into f of e, then we're supposed to get 3. If we put e into f dashed function, then we get 6 over e. Okay, so the first thing we're going to do is we're going to find the derivative, because we know that the derivative of this is going to equal 6 over e. So the derivative is f dashed x equals a times 1 over 2x plus b. You use the chain rule, you take the derivative of 2x plus b, you get 2. So 2a over 2x plus b happens to be 6 over e. Now this is a pretty difficult problem. Now let's rewrite this. So 2a over 2e plus b happens to be 6 over e. And that says to find the constants for a and b. By the way, this here, a natural log of 2x plus b is equal to a natural log of 2e plus b is equal to 3. Okay? And this problem I first tried to do by substitution and stuff, and it got really messy. And then I was just looking at it and I said, okay, well maybe I should just guess numbers. They're not going to make it really complicated, right? Normally the numbers are going to be like easy things. So when I looked at this, I'm like, okay, let's say that they were going to be really nice and the 6 is equal to that and the e is equal to that. So then what would a and b be? And then it's not like simplifying or anything. Like if there's like a factor to reduce it and stuff, that could get really messy. But let's say that 2a is 6 and 2e plus b is e. Then what would a and b be? A would be 3, right? If a was 3, then 2 times 3 would be 6. B would be negative e, right? Because if b is negative e, then 2e minus e is equal to e. So let's see if that works in the other equation. In this equation, does it work? So then we'll put 3 natural log of 2e minus e, so that would be natural log of e is equal to 3. Is that true? The natural log of e is 1. So, yeah, that's true. 3 times 1 equals 3. So, by, assuming that the numerator here is equal to 6, and the denominator here is equal to e, then we were able to guess the numbers and we confirmed it there. So that's the easiest way to solve this. You guess these easy numbers and it happens to be correct. Okay, so that's it for this one.